One of the things we need to do before we can do lines of best fit or scatterplots and things like that is we need to know how to take a graph that's provided to us and be able to accommodate the numbers that we're working with. Those ordered pairs we can easily graph on here, so this isn't a problem. But if we get to this graph that only goes up to 10 in the x and y direction, but our numbers are going up to 25 and 275 respectively, we have to adjust the graph a little bit. So here's my suggestion. This goes up to 10, but we need it to go up to 25. Take the 25 and divide it by 10, that gives you 2.5. So you could let every square, every unit be 2.5, which works out pretty well, because then we could say, well, 2.5 plus 2.5 is 5. So this guy would become 5, 7.5, 10, this would be 10. So 15, 20, and 25. So that works out pretty good. Same thing in the y direction. This graph only goes up 10 units up this way. We need to go up to 275 units. So if we take 275 divided by 10, that gives us 27.5 per unit, but that's an ugly number. Let's make it 25 and know that we'll have to go just a little bit above, but we don't care, it should be fine. So if every one of these little units is 25, then this would be 25 and this would be 50. This will have a different color. This would be 50. This would be 100. So every two squares would be 50 more. So that's 150. This is 200. This up here would be 250. And now we can plot these points. We need the point 15 and 165. That's 15 hours. Hey, by the way, it's a good idea to label the axes hours, and this is dollars over here. But we go to 15 and 165. Over 15 up to 165. That would be about maybe right there. And then 20 and 220, so we go 20 and up about 220 is going to be right about there. So that's it. We can start to plot our points and then connect the points and make lines. Even this one is accommodated. We go over to 25 and up to 275. That's just a little bit above this. So we get a point up about yonder and boop, there's our line. Life is good. So then what we do is we say, okay, let's take a look at, for example, the first unit or section in this unit that has us working with graphs and doing a line of best fit. Well, we have, if we look at the problem, we're looking at snowpack. So the table shows the time and days of winter after December 21st, 2009, and then the snowpack at the tree line of Wyoming Peak. So these are days after the 21st of December. The 21st of December is the first day of winter. So at time zero, on the 21st, there were 35 inches of snow. We can see as we go deeper and deeper into the winter, so does the snow get deeper and deeper. It gets up to 130 inches. So let's think about what we did. We have about 20 squares down here and about 18, so close to 20 this way. And let's think this through. On the x-axis, we need to go up to 50. So 50 divided by 20 is 2.5. Once again, we'd go by about 2.5. And if you go 4 2.5s, that's 10. So if we go over 4 units, this is 10. And then 12.5, 15, 17.5, this is 20. And then we can go 1, 2, 3, 4, that's 30. 1, 2, 3, 4, that's 40. And 1, 2, 3, 4, that's going to take us up to 50. That accommodates us in the x direction. And let's make sure we say that this is time in days down here. Okay, then on the y-axis, we have to go up to 130. We only have 18 squares, roughly 20 squares. 130 divided by 20 is 6.5. That's a weird number. So maybe we'd go by, we got to go by more than 5. We could go by as many as 10, and might as well make it easy on ourselves. Let's just go by 10. If choosing a number from 5 through 10, 6 through 10, we should probably go by 10s. So this is 10, 20, 30, 40, 50. This is 10, 20, 30, 40, 50. That takes us to 100. 10, 20, 30, 40, 50. That takes us to 150. And you can see that we can accommodate up to 130. Now, let's go through, and oh, by the way, this should be inches of snow. So we could put inches in parentheses and say snow over here. So we know it's snow in inches, and these are days into the winter. Now we go through all this. What's the independent variable x? That would be days after the first day of winter. What's the dependent variable? Snowpack in inches. Plot the points on the graph. So we got the point 0, 35. So let's use green for that. 0 and 35 is going to be about in there. Then we go After 10 days, 52. So 10 days, we're up to 52. That's just a little bit above the 50. That's right about there. Now, here's the, well, let's keep going. We get after 20 days, 78. 20 and up to 78. Well, this is 60, 70, that's 80. It's close to 80. It's right about there at 78. 30 days, 92. Over to 30, we're 8 units short of 100. There's 100. We come back down a little bit, so we're at about 92 there. Then we go 40 days, 112, 40, and up to about 12 past 100. So that's about right there. And then lastly, on the 50th day, we have 130 inches. So that's 100, 10, 20, 30. So we got about 130 inches right there. Now, here's what's interesting. Those points should not be in a perfectly straight line because this is real life. You don't get a predictable amount of snow every day perfectly exactly that much throughout the winter. You'll get a couple days of snow and then it might even melt a little bit, then some snow or whatever. So we don't expect to see a perfect line. So what we need to do now is to just try to get a line of best fit, a line that seems to balance those points out as best as we can. And it can be drawn freehand. In my line, I'll tell you right now, it may be kind of ugly, but I'm going to try to, I realize that that one dips down a little bit. So I think my line needs to come above that point a little and maybe, I don't know, I'm thinking about like so. That looks pretty good. Now, your line is going to look different from my line and probably slightly different from the person next to you. So in a moment, we're going to get a line of best fit, but it may not be exactly the same as the equation of the person next to us. That's okay because we're doing it freehand. The thing we learn after this, very shortly, is to put the data into a calculator and let the calculator come up with the greatest line of best fit of all time called a least squares regression line. We're just freehanding it. Now here's what we need. We know from what we've been doing, as long as we can find 2 points on the line, then we can figure out what our line of best fit is. And my suggestion would be it doesn't have to be any of the, 2, 4, 6 points that we had in our data set. Instead, you're looking for 2 points that are on our line of best fit that are easily identified. I'm looking on my graph right here. This right here, I'm hitting an intersection of 2 grid marks. This would be 32.5, and that would be 100. So I'm going to say one of my points is the point 32.5 and 100. Then I'm going to find another place where the line hits, and I see one right up here. This line is hitting exactly in the intersection of 2 grid marks. That's 45, and this is 130. So I've got at 45, I've got 130. Now remember what that means. After 45 days, that's the snowpack. After 32.5 days, that's the snowpack. So this answers part A, give 2 points that you could use, and then part B, use those 2 points and write an equation. Well, which form of an equation would we like? Well, since neither one of those is a y-intercept, and we could use the y-intercept down here, but let's make it more interesting. Since neither is a y-intercept, we're going to go with this bad boy right here. We're going to go with point-slope form. So we have 2 points we could use. I'd probably use this one because it doesn't have a decimal. And then we just need the slope. So we know how to find slope. We're going to find slope by taking the second y, 130 inches, minus the 100 inches, divided by the second x, which was 45 days, minus the first x, which is 32.5 days. Now this meant that we got a difference of 20 inches of snow. We gained 20 inches of snow in 12.5 days. We could bust out the calculator and see what that is. I believe that would be 1.6. So we're going to make that slope be 1.6. So we're saying that we're going to gain about 1.6 inches per day. And so my equation that I'm going to get, again, it's going to be slightly different than everybody else's. That doesn't show up very well. I'm going to go with y minus my specific y here of 130 equals my slope of 1.6 inches per day, and then x minus the number of days of 45 that was in my ordered pair. I'm good. That's my equation right there. That's a legitimate form. Okay, does your scatter plot have a positive or negative correlation? It's positive. As the days go along, the points are rising, the depth of the snow is increasing. What's the slope? My slope is 1.6. Explain what this slope is in the context of the situation. I said it as we went along. I know we're doing the change in y, which is the change in snow over the change in days. We gained 20 inches of snow in 12.5 days. That comes out to 1.6 inches of snow per 1 day. Now again, depending how you eyeball this, you're going to get something that could be somewhere between 1 inch and 2 inches. If it's any different than that, you probably made a boo-boo. And then what are the coordinates of the y-intercept? Well, we could go down here, and our y-intercept, my line is pretty close to the 0 and 30. Actually, mine's about 0 and 30. So I would say my coordinates, where am I? For the y-intercept are 0 and 30. You might come up with 0 and 35, maybe 0 and 32, whatever. Explain what the y-intercept tells us in the situation. 0 days after the first day of winter. So on the first day of winter, we've got about 30 inches of snow. Use your equation to find the snowpack 25 days into winter. So I could put 25 days there. 25 minus 45 is going to be negative 20. I will take 1.6 times the negative 20, and that would give me negative 32. And then to get y, I would add the 130 to that, and what I would get is y is equal to 98. Okay, you know how to do an equation, so I'm trying to save time here, but we would predict about 98 inches in that case. How many days in winter will the snowpack on Wyoming Peak be? About 100 inches? Hey, that's about it. About 25 days in, we should expect 100 inches. That's according to my estimation of what I got. You might have something different. Based on this thing, it might be closer to 35 days or whatever. You could see it off the graph here. My graph, see, I had it hitting at about 100. And so, again, we're going to have some error. In fact, honestly, I'm not real thrilled by my prediction there about 98 inches. But it's because maybe my eyeballing or my drawing the line is off a little bit. So that's why just doing a line of best fit by hand is not going to give us a super accurate indication of what's going on. We're going to be better off to learn what we learn tomorrow in class, which is let's let the calculator do it. It does a much better job. So that's an indication of what we need to do with lines of best fit, drawing freehand. We'll get to least squares regression line, the powerful stuff on the calculator next time.